Find the length of the altitude of an equilateral triangle with side length 14 root 3. So, we draw ourselves a nice equilateral triangle. We draw the altitude of that triangle, which is, of course, that segment which is perpendicular to the opposite side. And then, what do we know about this equilateral triangle? Everyone's still talking about band. Yes, Aaliyah, I was getting at that. First, what do we know about the equilateral triangle? We know that the equilateral triangle's angles are 60, 60, 60. But then, once we draw that altitude, once we draw that dotted line, then we see our 30, 60, 90 right triangle, which has that awesome little trick, that rule that works every time. So, we've got x root 3, and 2x as our side lengths. They tell us that the side length of the equilateral triangle is 14 root 3. Now, you could do Pythagorean theorem. You could say, oh, this is 14 root 3 cut in half. You could call that 7 root 3 and do Pythagorean theorem, but that's way more work than using your 30, 60, 90 rules. So if you're still using the chart, you're welcome to. If you don't use the chart anymore because you're so used to the rules, if you just write it directly on your triangle, that's fine as well. What do we have, and what is it across from? So we have 14 root 3, and it's across from the 90-degree angle, so it's our hypotenuse. Okay. So how do we get from here to here? Kind of already did that. Divide by 2. So 7 root 3 is across from 30, and we did that right here. But what are we really looking for? We're looking for the altitude, and the altitude is across from the 60. So across from the 60 is what we're looking for. So we really need this one right here. 7 root 3 root 3, which is a beautiful number. It is. Good. Look, you had your units and all. 21 centimeters. Because, of course, square root 3 times square root 3 is 3. So we're really just doing the product of 7 and 3. Homework answers. Which ones are we working today? Number 7. All right. Number 7 is not special. So when the triangle's not special, when we don't know its angles, we always resort to Pythagorean theorem. That is where we go directly to Pythagorean theorem. I'm going to call this side A because we're going to find A first. We're not going to find X first. If we call that missing side X, then we'll think when we're done we have the final answer. We'll forget to multiply by 2. So this almost looks like a Pythagorean triple, 6, 8, 10, right? Except the 8's the hypotenuse, and so it's not a Pythagorean triple because the 10 would need to be the hypotenuse for that to work. All right, so 8 squared minus 6 squared equals A squared. We simplify the left side. 28 equals A squared. Opposite of squaring something is square rooting. And the square root of 28 is 2 root 7. Of course, the other side, it's isosceles, so those are equal. They're both 2 root 7. Are we allowed to add those? Yes, right? They're like terms. They're root 7s. And so 2 root 7 plus 2 root 7 is 4 radical 7. Number 14. 13 and 14 are very similar. They are Pythagorean theorem, which turns into Pythagorean theorem, which turns into Pythagorean theorem. Both of those have right triangles where you find a missing side of one, and that's the side of the next right triangle, and then you do Pythagorean theorem on the next right triangle. Okay? So I'm going to do 14, but 13 is really the same way. On 14, we have 1, 2, 3 right triangles. They're all right triangles, so they're all eligible for the Pythagorean theorem. It's actually beautiful because they're all Pythagorean triples. So if I do 17 squared minus 8 squared, and I don't trip over the smartboard, then we get 225, and we square root that, and that missing side is 15. And then if I do 10 squared minus 8 squared, 36, and the square root of that is 6. And now I'm doing Pythagorean theorem one more time. 15 squared plus 6 squared, 261. Oh, that one's not pretty. So you factor tree the 261, and you get 3 radical 29. These were on your last quiz when you're trying to decide if it's acute, obtuse, or right. First of all, on this one, you need to decide which one is your C. You need to find which one is your largest side. And if you don't know the square root of 34 off the top of your head, you might want to ask your calculator. It's 5.8. So that one is your C. So we always write Pythagorean theorem backwards. C squared, and then A squared plus B squared. The square root of 34 squared is 34. 3 squared plus 5 squared is 34. They are equal to each other, therefore it is a right triangle. If we had gotten less than, it would have been acute, and if we had gotten greater than, it would be obtuse. All right, number 22. Similar to the other one that involves a square, this time you're given the diagonal, which is 12. A diagonal of a square always creates 45, 45, 90 triangles because that triangle is both isosceles and right. It's isosceles. So we know we can use our rules. Remember, when you're headed towards a hypotenuse, you multiply by root 2. When you're headed away from a hypotenuse, you divide by root 2. So it's 12 divided by root 2. Rationalize 12 root 2 over 2. 6 root 2, final answer. Okay, last one, 23. Find the length of a side of an equilateral triangle whose altitude has length 6 root 3. I'm pretty sure we did something really similar to this in the warm-up. This is our 60, this is our 30, this is our 90. So across from 30 is 6, and across from 90 would be 12. 6 root 3, 12. First, let's read this sentence and let's determine the truth value. If c squared is less than a squared plus b squared, then the triangle's equilateral. All right, so I'm getting a lot of disagrees, and you are right. If c squared is less than a squared plus b squared, then the triangle is acute. Not equilateral necessarily, but acute. So the truth value of the original is false. All right, now I want you to find the converse of the sentence and determine the truth value of the converse. Is the converse true or false? So the cool thing is the converse of that sentence is true. If it's equilateral, what are its angles? What are its angles? About 60. 60, 60, 60, right? So what kind of triangle is that? If it's equilateral, it's an acute triangle. So this is saying if the triangle is acute, then c squared is less than a squared plus b squared. And that is true. Equilateral triangles are acute. So the original is false and the converse is true. Let's do one more logic problem. If a triangle is isosceles, then its angles measure 45, 45, 90. Agree or disagree? If its triangle is isosceles, then its angles measure 45, 45, 90. All right, what's that called? What did I just do? What's that called? A counterexample, right? I drew an isosceles triangle. Are its angles 45, 45, 90? No, it has to be both right and isosceles. It has to be isosceles to be a 45, 45, 90. Now, if we did the converse, if its angles are 45, 45, 90, then it is isosceles. The converse would be true. Yep. So the original was false. The converse was true. Go ahead and begin on your quiz.